On today's video, we're going to do some more trailer light fixing. Hey there outdoor YouTubers, it's Dave Knetter from Knetter's Practical Outdoors, and today we're going to talk some more about trailer lights. Okay, this is part 2 of a multi-part series of videos that I'm doing on how to fix your trailer lights. Alright, and this part 2 we are just going to deal with gaining some understanding of how trailer light circuits work. Okay, because that's going to be very important with subsequent videos as far as troubleshooting the problems that are going to come up. Okay, we're going to need to have some basic understanding of how trailer light circuits work. It's going to be pretty straightforward and pretty simple, okay, but some of these basic principles are really going to help us when we go to troubleshoot our trailer lights. Okay, and I've got this little test set up here. Alright, we've got our 12-volt battery. It's just a small one. Okay, that's going to simulate our car battery. Okay, we've got our plug or our harness that comes out of our truck or car, the one that comes out of the vehicle right here, and we've got these other leads. Okay, and when I touch these different leads to the positive side of the battery, that's going to kind of simulate those switches coming on for brakes, blinkers, running lights, that sort of thing. And as you can see, the white wire, which is associated with this lone odd pin, that goes to the negative of the battery. All right. Okay, then that's how these 4-pin flat plugs work. Okay, and as I said in part 1 of this series of videos, I'm always going to be referring to the 4-pin flats. They're really common. Okay, but many of the principles that we use and talk about will apply to all different types of harnesses for trailer lights. But we're going to just deal with the 4-pin flats. Okay, so here's our harness coming out of our vehicle. We're going to be able to simulate turning stuff on and off by touching these other wires to the positive of the battery. Here's the harness on the trailer side of things. Okay, we got all the wiring here, our green, yellow, brown. Okay, and we've got that hooked up to these lights. Okay, and we can just kind of run through things here. All right, we're going to plug this in. All right, we'll plug this in, and we'll start off with our green. Okay, our green wire is our right breaker or our right blinker. Okay, and we'll touch it to the positive side of the battery, and here we go. We've got the right side to light up. Okay, and what your vehicle does is, if we were doing the right blinker, your vehicle just toggles it on and off. That's a blinker. Hold it on there steady. That's the brake. Okay, so we got that. Yellow, left side, left brake, left blinker. Again, the vehicle just toggles it on and off to be a blinker. Okay, now we'll go on to our brown. Brown is our running lights, and there we have them both on. We have the lights on the side also on. That's our running lights. So what's happening when we touch the green wire to the positive of the battery? Okay, the electricity is traveling through the green wire. All right, through the plug onto the green wire on the other side of the plug. This is the trailer side. Okay, on through, the green wire circles around in this this loop of wires, on through here, and it comes out here, and it goes to this fixture. It goes to our right fixture, our right side fixture. It goes through the fixture, through the bulb, through the circuitry. If this is an LED fixture, it goes through the circuitry and comes back out, and it comes out on this white wire. Right, the white wire is the common, the negative, kind of the ground. That's the return circuit for all the other wires. That's why this white wire is connected to this negative. These ones aren't. These ones carry the voltage through to the fixtures, and the white wire is the return for all of these other three. Okay, so the electricity comes down through the green wire, through the fixture, out onto the white wire, through the white wire. Okay, back to our plug, through the plug, down through here into the negative of the battery. Okay, that's just a quick overview of how these trailer light circuits work. Okay, now I'm gonna go full geek on you. Okay guys, like I said, I'm going full geek on you. I broke out the dry erase board, And I think it's pretty important to go through this little diagram I made because we want to be clear about a couple of things, okay? One of the things we want to be clear on is the white wire, the ground wire, isn't always a wire, okay? And I'm going to explain that to you in just a little bit here. All right? And the other thing I want to explain is the difference between short circuits and open circuits, okay? And there is a distinct difference, okay? Now, a lot of people refer to any problem, any electrical problem when it's not working, a lot of times they refer to it as a short. You know, you tell your buddy, oh yeah, hey, my brake lights aren't working on my trailer, and your buddy might say, oh yeah, you got a short circuit in that. Okay, well, sometimes that's true, sometimes it's not, okay? Shorts and opens are very different, and we're going to talk about both of them here. But real quick again, I'm going to go through kind of what takes place, you know, when lights on your trailer come on, all right? We've got the truck side over here. We've got the trailer side over here. This dotted line separates them. Here is our plug, okay? All right, we've got our battery, 12-volt battery, positive, negative. This is a fuse, all right? And this is going to be our brake switch, okay? And this is our brake light on the right side. We're just going to kind of deal with the right side for right now, okay? We're just dealing with the green wire that is our right side. I'm showing the other two wires, you know, the brown and the yellow, but we're not going to discuss those right now. There would be another brown and a yellow coming out this side, but we're not going to talk about them right now, just to kind of get the idea of how this works. Okay, so let's say we go ahead and we step on the brake. We've got our trailer plugged into our vehicle, or in this case our truck, right? And we step on the brake, this switch closes. So now this positive voltage coming out of our battery can travel up through here, through the fuse, through this switch, onto this green wire, okay, onto the plug, through the plug, onto the green wire on the trailer side, okay, comes to the bulb, makes the bulb light up, all right, and then it leaves the bulb or the fixture and goes onto this white wire, okay, then it travels through the white wire, back, up and around, back to the plug. Now it travels through the plug, and this is still a white wire right here, through this white wire, and back to the negative of the battery. Okay, and that's how it works. You know, when you would step on your brake, it would close a switch or close a relay, and it would complete this circuit. It has a good flowing circuit, it has a path back to the negative. Okay, now, like I said before, sometimes these white wires aren't always wires, and I'll explain that to you. Now, a lot of times, on the vehicle side of things, your battery will be attached to the frame of your truck, okay? Those will be the wheels. This is going to be our frame of our truck, and this white wire is just electrically attached to the frame of your truck. And then the white wire coming out of the plug on the vehicle side of the harness is also attached to the frame of the truck. Okay, the frame of your truck conducts electricity. So oftentimes this is actually what's going on. That voltage comes up through here, through the plug, through the bulb, lights it up, comes back through on the white wire. White wire goes through the plug, comes out on the vehicle side, and then it's grounded to the frame of the vehicle. Passes through the frame of the vehicle and onto the negative of your battery. And that's very often how these things are wired, okay? And you know what? It's actually the same thing on the trailer side, okay? This is what I was talking about when I said the white ground or negative wire oftentimes isn't always just a wire, okay? And the reason I want to stress this is a lot of the problems we're going to run into are going to have to do with these white ground or white negative, white common wires being attached to the framework on your vehicle, and they also attach to the framework of your trailer. Okay? Let's just pretend that that is the frame of our trailer. And oftentimes that's how these things work too on this side. Oftentimes this white wire, when it comes out of the plug on the trailer side of things, it's electrically attached to the frame of your trailer, okay? And then the white wire coming out of your fixture or away from your bulb is just electrically attached to the frame of your trailer. Okay, that's how these things often work. So again, the electricity passes through here, through the bulb, out this white wire, electrically attached to the frame of the trailer, through the frame of the trailer, okay, back to the white wire, and up to the plug again, through the white wire, through the frame of the vehicle, to the negative of the battery. Okay, and again, like I said, it's very important to understand that, because a lot of the problems that we're going to run into with trailer lights are going to have to do with these electrical points where they're attached to the framework of the vehicle or the trailer. A lot of times, trailers may not have good continuity through the full length of them, and that's going to cause us problems. So we need to understand this, okay? And we're going to get into all of this in the other videos in this video series, okay? But for this one, I just want to kind of make sure we understand, you know, that we're talking about the same thing, okay? So when I say that the white wire is not always a wire, that's what I mean. A lot of times we are using the frame of the trailer and the frame of the truck as a conductor or as a wire, and we need to understand that because a lot of problems are going to arise from that. Okay, so the other thing that I talked about that we want to be clear on is the difference between short circuits and open circuits. Okay, now an open circuit is just what it says. It's an opening somewhere in the circuit that does not allow the electricity to flow. Okay, and one of the most common open circuits, especially with incandescent bulbs, is a burnt bulb. If you can imagine, that would be a filament of our bulb, and it burnt open, so the electricity comes through here, through the plug, back onto the green wire, and it stops right there. Our bulb is blown, so it's an open circuit. The filament of our bulb is open, electricity can't pass through it, and it won't light up. Okay, we'll reattach this, because that's not the only open circuit we're going to get. Okay, another open circuit, like I said, a good one that happens quite a bit, a common one, is where the white wire attaches to the trailer. Okay, that can become an open circuit. And a lot of times, it's not necessarily that this white wire broke off and it's not attached. A lot of times, this white wire, especially coming out of this plug on the trailer side, will be screwed down or bolted down to the trailer frame, and sometimes corrosion will set in. Or even though it was screwed down on top of some paint, and there wasn't a good electrical connection, and after a while it just isn't conducting electricity. So a lot of times an open circuit is a bad connection, again, especially when we're connecting this white wire or our grounds to the trailer frame or even the vehicle frame. Okay, so that's kind of a common open circuit too. Alright, we're going to reattach this. Another open circuit could just be this green wire. This green wire, right before it gets to the fixture, it's kind of hanging out the back of the trailer, maybe on a boat trailer. It kind of comes out of the framework of the trailer and kind of comes up, and it's kind of exposed there where it attaches to the fixture, and some brush or something snagged it and just broke the wire right there. Again, now we have an open circuit. And all these open circuits are not going to allow our bulbs to light up. Okay? Now, let's think about another scenario. Let's say this wire did break, okay? But let's say it broke off inside the framework of the trailer, okay? And let's say instead of just hanging out in the middle of the air, just flopping around off the back of the trailer, let's say this wire came down and it broke, and the copper part, you know, not the insulation part on the outside, but the copper part of this green wire was touching the frame of the trailer. You know, now what would happen? Well, our bulb would not light up. You know, I think that's pretty obvious. But here's another thing that happens in that scenario. And this would be considered a short circuit, okay? Because the electricity coming through here, through the green wire, can't get to the bulb. It actually is a shorter circuit. It comes down to the frame and then returns back, okay? And you might say, like, well, you know, what's the difference? The bulb's not lighting up. We got a problem. We got to fix it. Well, this is going to be quite a different scenario, because what's going to happen is this circuit no longer has the resistiveness of the bulb. It doesn't have the resistance of the bulb. And the bulb carries resistance, and that's pretty important, because what will happen is a circuit with no resistance the amps will skyrocket. Okay, there's really no need to really get into Ohm's law and the math involved and everything, but know this: when you have a short circuit, the amperage skyrockets, and what's going to happen is this fuse is going to blow. Okay, so if you're blowing fuses, that's telling you that you have a short circuit somewhere. Okay, if your trailer lights just aren't working, oftentimes that's going to be an open circuit somewhere. Okay, so that's the difference. So the fuse blows, and we want it to. That's a very important aspect of all this. We need those fuses to blow, because if that fuse doesn't blow, this circuit continues to generate, amperage. The amperage is skyrocketing. These wires will actually heat up. They'll melt the insulation. Fires can start. That's really the purpose of this fuse, is to make sure short circuits don't cause any kind of catastrophic failures, don't melt things, don't start fires, all that kind of business. Okay, so that's the difference. You guys might have watched some other videos, and like I say, sometimes people use the term short circuit to apply to anything that's not working, in the electricity world. Oh, that trailer's not working. Oh, even the light in your house, oh, it's not working. It must be a short circuit. It's like, well, short circuits cause fuses to blow, or in the case of your house, breakers to trip. But as far as our trailer lights go, short circuits cause fuses to blow in your car. Okay, open circuits, just don't work. So actually what happens, as soon as this fuse blows, it turns this short circuit into an open circuit, because it disrupts the flow of amperage and voltage through this circuit. So it quickly turns our short circuit into an open circuit, which is very important. Like I said, we don't want wires melting and fires starting. Okay guys, thanks for hanging in there with me. Okay, I just felt it was very important that we're all on the same page, that we all have a basic understanding of how these trailer light circuits work. Okay, very important. In other videos, in this video series, we're going to get really into it. We're going to be troubleshooting and fixing trailer lights. We're going to be going over all different scenarios, but before we get there, we need to have a basic understanding of how these trailer light circuits work. Okay, and just to recap, one of the things we learned the difference between short circuits and open circuits. Okay, like I said earlier, maybe you've talked to people in the past, maybe you've watched some other videos, and they kind of play it a little free and loose with the term short circuit. They kind of apply short circuit to any non-working circuit, but remember, we learned that's not true. A short circuit is when the circuit is shorted and it doesn't go through the load. It gets cut short of in this case, our bulb, grounds out, and does have a return path. Amps go high, fuse blows. Remember, the open circuit is just an opening in the circuit. Doesn't blow fuses, right? Blows fuses, short circuit, just not working, open circuit. Okay, that was an important thing that we learned. The other kind of principle of how trailer lights work is the frame of the truck is oftentimes used as a return path back to the negative of the battery. That white wire attached to the frame of your truck, and the negative of your battery attached to the frame of the truck. Same thing on the trailer side. That white wire is grounded out to the frame of your trailer, just like it is on the fixture side. It's grounded out. And there's a few different ways that works. Some are pretty obvious, some aren't, but we're going to cover all that in other videos in this video series. And here's a perfect example of what I'm talking about. If you look at this, this is the wiring harness that you would buy if you're going to rewire a trailer. And if you look at it, this is the plug on the trailer side, and we've got all kinds of length with all of our wires except the white one. And this is how it comes right out of the package, right? There's all kinds of length in our yellow, our brown, our green, because these wires have to reach all the way to the back end of the trailer and attach to the fixtures, right? But this white one, it's only a couple feet long, because this white wire is intended to be grounded right away at the front of the trailer, either bolted down, screwed down to the metal framework of the trailer somewhere. So like I said, this is how it comes right out of the package. This white wire is only a couple feet long, and that's why, if you're ever wondering, that's why, because the white wire is not intended to go back to each fixture, so it doesn't have the length. Okay, so those are the things we learned about today. All right, And in the other videos in this video series, remember this is just part 2 of a multi-part series of videos on how to fix your trailer lights. It's just part 2, kind of getting us all on the same page with how the trailer light circuits work. Okay? Anyways, guys, hey, remember to hunt, fish, laugh, repeat. This is Dave Knetter from Knetter's Practical Outdoors. Hey, thanks for watching and God bless.